In this section, we'll be talking about the energy changes or heat of reaction. And whenever we talk about this topic, we normally run across important concepts like the exothermic and endothermic reaction. So, what is exothermic and what is endothermic reaction? Well, whenever we talk about endothermic reaction to start with, these are reactions that absorbs heat from the surrounding. Okay, and exothermic reaction is just the opposite. They give out heat to the surrounding. Okay, so what makes these two reactions different? Well, the difference in the two reactions is associated with the energy change that occur when the reaction takes place. So take for instance, if we have this reaction where we combust coal. So if we have a coal, or let's say we combust coal to relate with, and that's usually in the presence of oxygen gas, and it would give us CO2 and water. So when this reaction happens, a lot of us have seen this reaction before. It necessarily doesn't have to be coal. It could also be paper or any material that's hydrocarbon. What happened is that we also experience an increase in temperature around the burning material. So we also have an associated heat energy release. Okay. So what is happening is that some reaction is happening here that is breaking the bond in the coal and also in oxygen. So bonds are broken in the reactants. Okay. And in the products, we are forming bonds. Bonds are formed here. And it is very important to know that whenever you form or you break bond, energy is involved in this process. Okay, so when you break bond, it takes energy. Energy is taken in. And when you form bond, energy is released. Okay, so the difference between the energy taken in and the energy that is released will determine if the reaction is endothermic or exothermic. So, and that difference is called the heat of reaction. So heat of reaction is equals to energy released when bond is formed minus energy released. This should be R, and bonds are formed minus energy released. When bonds are broken. Okay, so this will either be positive or negative. Okay, because the value that we obtain for this heat of reaction is dependent on the value for the energy that is released when bonds are formed and energy released when bonds are broken. Don't worry, we're going to go more in depth into this concept in the following sections or episode of this video, because it is definitely more than what I'm describing right here. But this is just an introductory video to introduce us to this concept. So stay tuned. And so this can either be positive or negative, depends on what these two values are. So if it is positive, the reaction is endothermic. And if this is negative, the reaction is exothermic. Okay, and this heat of reaction is represented as delta H. And now you need to know, okay, there's delta H standard and normal delta H. And we'll discuss more about that, but just know that the heat of reaction is represented as delta H. Okay, so we can also draw this in terms of energy profile diagram. Okay, so I'm just gonna shift this over. Okay, well, so if we were to draw this in terms of energy profile diagram, okay, so if this is the energy on y-axis and this is a reaction coordinates or pathway on x-axis. So if we have a reactant, in this case we have a coal and oxygen, but let's just make it hypothetical. And we call this reactant. And we'll call this product. Okay, so if we look at the energy for the product relative to the reactant, the product is higher in energy than the reactant. So this reaction would have a positive value for the heat of reaction. So this delta E, which is equals to delta H, will be equals to positive because the product is more than reactant. And if you look at what we described previously, we set to calculate the delta H, which is energy released when energy released when bonds are formed, which is bonds are formed in the product, which is equals to energy released when a product are formed, minus energy released when bonds are broken, which is the energy released when reactants are consumed. So now we look at the energy of the reactants and the energy of the product. So energy of products minus energy of reactants will give us a positive value. So that is why this reaction, I describe it to be endothermic. So this is the energy profile diagram for endothermic reaction. Okay, the next one is the exothermic reaction. So if we have this energy again and reaction coordinates. So if we have something that looks like this, So again, we have reactants, and then we have products. So in this case, the reactants are more energetic than the products. So delta E here which is equals to delta H will be negative. Again, that is because we are subtracting reactants from products, right? Because heat of reaction, which is delta H, is energy released when bonds are formed minus energy released when bonds are broken. Bonds are formed in the products and bonds are broken in the reactants. So going back to the diagram, if bonds are formed in the products and bonds are broken in the reactants, that means that products minus reactant in this case will be negative because the product is smaller in energy than the reactant. So this is negative, and this will be exothermic reaction. Okay. Now, how do we know in terms of heat? So reaction container will be cold in endothermic reaction because it absorbs heat from the surrounding. So the reaction container wall will be cold. In this case, the reaction container will be warm. And that is that about endothermic and exothermic reaction.